This is the last in a three-part lesson series here dealing with permutations and combinations and working within the formulas. We're going to start by actually going back to lesson 2, and you'll need the handout for lesson 2. And lesson 2's handout is here. You can get it, you should have it with you, or it's in downloadable at puremath30.com. We're going to be talking about combinations, then we're going to jump into lesson 4 and actually get a little deeper working with the formulas themselves. So if you turn, and I believe it's lesson 2, part 6, other types. It's right at the back of the handout of lesson 2. We're going to be looking at these combinations. Again, combinations. Order is not important. And here's a series of combinations, sort of formulas that could be useful for you, but they're not given on a diploma exam. A lot of them can be thought through and actually figured out on your own on the diploma, or if you need a specific one, they'll probably give it to you in the diploma itself. But we're going to work with these equations. We're going to first just do them through calculator skills, then we'll look at them with the formulas later on in this lesson. So the first guy we got for handshakes, diagonals, multiple combinations, making shape, choosing one or more items from a bunch. So we'll look at example 1. It says 12 people at a party shake hands once with everyone else in the room. How many handshakes have taken place? So if you look, that's up here, the handshakes of the teams, where it says NC2, N is the number of people or teams. So we have 12 people in the room. They each need to shake hands. It doesn't matter the order they shake hands with another person. The reason this is 2, it takes 2 people to shake hands. So 12 people, 2 shaking hands. How many ways can this happen? If you look at your calculator, this turns out to be 66 different handshakes that would happen in this room. That's it. We'll look again later on with the formula later on in this lesson. Example 2, a polygon has 7 sides. How many diagonals can be formed? Well, the second one up there says diagonals. It says n choose 2 minus n, where n is the number of sides. So if we look, a polygon has 7 sides. We'd be saying 7 choose 2 minus the 7 sides. This would be how many diagonals could be formed in this shape. Again, you could put this into your calculator and we'd determine that it's 14. This one as well should make kind of sense here, the formula itself. Just if I said that I had a 4-sided shape and I need to make diagonals, that means I'd have 4 sides like this. The diagonals here we know are only 2. So we're saying 4 choose 2, and now I subtract those 4 that are along the edges here that aren't actually diagonals. That's why we're subtracting those, like in our example 2, the 7, because the 7 actually form the sides, don't form a diagonal. But we could use that formula right from up there. Example 3. If each of 8 teams in a league must play each other 3 times, how many games would be played? Well, up here again, we got the handshakes and the teams as the first equation. We know there's 8 teams, and they each need to play. It takes 2 teams to play. So if we did that, that would be everybody playing each other once. Once I get this number, if they have to play each other 3 times, I have to multiply this by 3 to get 3 games, which means they play a total of 84 games. Example 4. If there are 15 dots on a circle, how many triangles can be formed? Now up here, this comes from making shapes. Right there. The points on a circle, the number of vertices. If we're making a triangle, we need to have 3 vertices to actually make a 3-sided shape. So if we look at that formula, it's saying n choose k, n is the points on the circle, k is the vertices. So here there's 15 dots on a circle, there's 15, and I need to choose, I'm making triangles, so that means I actually have to choose 3 points. If I was making squares, it would be 4 points. Pentagons, 5 points, and so on. So I just have to put that in. If there's 15 points on a circle, I should be able to make 455 different triangles. And the last example, example 5. In how many ways can you choose one or more of 12 different candies? Well, that's one of those up top here again. Choosing one or more, right there, because it's a base of 2, because you either choose it or you don't, that amount of times. Okay, So we go here, it's 2 choose 12 minus 1. This is how many ways, if I had 12 candies, you could take one or more. Well, if we looked at our calculator and tried to do this, 12, sorry, it's 2 choose 12 minus 1. There's like 4 large different ways we can do this. So 4,095 different ways you could choose one or more candies. So we're going to take this information now and we're going to jump into lesson 4. And lesson 4 looks like this. It can be downloaded. You should have it. It can also be downloaded at puremath30.com, and you could be looking at that. And we're going to be getting into the last little section on here, which should look like this. And it deals with the same questions we just were looking at. So we're going to look at them now. They take a little bit of a twist. You're going to have to refer back to those little formulas at the top of that in lesson 2 to answer some of these questions. So let's take a look. So the first question is saying there are 78 handshakes in a room, and each person shook every other person's hand one time. How many people were in the room? If you look back, the formula for handshakes was n choose 2, gave us the number of handshakes. So in this case, they're saying n choose 2 gives us 78 different handshakes. We're trying to figure out the n, how many people were in the room. So we have to go back to our formula for combinations, which off your formula sheet you should be able to find is n factorial over r factorial times n minus r factorial. So we could rearrange this formula or write it in formula terms as n factorial over 2 factorial n minus 2 factorial equals 78. We start to simplify. The top is n times n minus 1 times n minus 2 factorial all over 2 factorial n minus 2 factorial. The n minus 2's cancel. This is still equaling 78. 2 factorial right here, we already know that that equals 2, so that's n minus 1 over 2 equals 78. If I take my work up top here, I could times both sides by 2, and I get n minus 1 equals 156. I can distribute in this n squared minus n equals 156. Bring this over to make a quadratic, so n squared minus n minus 156 equals 0. Now we have to factor this quadratic, so it needs to multiply to a negative 156, add to a negative 1 in the middle. I'll help you out. These are n minus 13, n plus 12. Those are my two solutions, which means, or sorry, my two factors, which means this gives me a solution of maybe there's 13 people in the room, and this one gives me a solution of maybe there's negative 12 people in the room, which right off the bat you should know that this is an extraneous solution. There had to be 13 people in this room to have 78 handshakes. So solving it algebraically, which you will be asked to do on checkpoints and strand exams, is important. Let's look at the next one. If there are 56 games in a series and each team played every other team twice, once at home, once and away, how many teams are there? Looking back at lesson 2 again, this is the same formula. We have NC2. Every team, the N, has to play, it takes 2 teams to play, so that comes the 2. But now it's saying they played each other twice, which means whatever this is, we have to double it. So this is the games being played twice. We know this equals 56. So now we have to solve this. First thing I would do is divide that 2 out, and I'd be left with NC2 equals 28. Put this into the formula for combinations. N factorial 2 factorial n minus 2 factorial is 28. Then we get n minus 1, n minus 2 factorial all over, and I'm just going to write 2 because 2 factorial is 2, over n minus 2 factorial. These are canceling, still equaling 28. which if I take my work up to the other side here, we should see the numerator I can simplify to n squared minus n. That's distributing in that n. I can multiply this 2 to the other side and get 56. Bring the 56 over, n squared minus n minus 56 equals 0. Factor and solve. And if you look at your solutions, we're either saying there was either 8 teams in this league or there was -7 teams in this league. Again, that's an extraneous solution. There must have been 8 teams in this league. The last example in here is talking about polygons and diagonals. How many sides are there? You'd have to go back and saying if a polygon has 54 diagonals, how many sides were there? The formula that they gave us on back in lesson 2 was NC2 minus n equals 54 to figure out the diagonals, because the diagonals is 54 of them in this case. We're trying to solve for n. It's a little bit more complicated here because we have this n floating around. So let's take a look. We're going to put this in factorial form. N factorial over 2 factorial n minus 2 factorial minus n equals 54. We could clean this up. Hopefully now you're getting really good at simplifying these factorial formulas. Again, I'm going to put 2 in the denominator because 2 factorial is 2. And n minus 2 factorial. This still has minus n equals 54. The n minus 2's cancel, which leaves me with, I'm going to simplify this, n squared minus n all over 2 minus an n equals 54. Now, in the past, we just multiplied this 2 out. We can't be doing that right now because we still have this minus n floating around. So I'd suggest probably putting that over to the other side. I'm going to move my work up top on the other side again. So I could have n squared minus n over 2 now equals n plus 54 because I took that negative n, added it to the other side. Now I can go and multiply the 2 over. So I'm going to get n squared minus n equals 2 times n plus 54, multiplying all of that. So that's 2n plus 108 and n squared minus n. Now the same rules apply. We're going to bring everything over to one side, factor the quadratic, get rid of any extraneous solutions. So I'm going to get n squared minus 3n minus 108 equals 0. If we factor this, we get n minus 12, n plus 9 equals 0, which gives me right here, this gives me a solution of 12. This gives me a solution of -9. Saying how many sides were there in this polygon? Well, we know there can't be -9 sides. That's extraneous. So this polygon had to be a dodecagon, which has 12 sides. So here was using that information about different types of questions that could be combination questions and using it with the equations and doing a lot of factoring to try to find possible solutions. So again, I'd suggest you work through the questions. The answers are provided. And then we'll move on to another lesson when I return.